We're now going to look at a new category of word problems. A lot of textbooks would separate out the money problems from the mixture problems as if they were different types of problems, when in fact the money problems are mixture problems and can be worked the same way. Now the basic procedure, the basic setup for most of these problems is going to look something like this. We are, of course, putting together or adding together two different ingredients to form a mixture. And the ingredients that we mix together are going to have two important characteristics that we're going to need to look into. First of all, each ingredient is going to have an amount. Now that amount may be given in the problem, or that amount may be what we are looking for. Also, each ingredient is going to have with it an associated either a percentage or some other type of value, sometimes a dollar figure. And again, that goes for each ingredient. A percentage, like with a chemical, or a value, like a dollar value. When we mix these two ingredients together, we're going to get a mixture that again has two components. They will not always give you these two components. Sometimes they'll just give you the product of these two components. But either way, there's going to be an amount and an associated percentage or value, and we will often multiply these together. Now my first example is going to be a money problem, since money problems can be worked as mixture problems. So let's take a look at the problem. We're going to take $7,000 and we're going to split this $7,000 up into two investments. It's going to go partially into an 8% investment, and the other part is going to go into a 5% investment. Now what we know is at the end of the year we need to earn a grand total of $476 in interest. So let's start putting things into the formula. First of all, the value, or the percentage in this case, for the first investment is a 0.08. That represents your 8%. For the second part of this mixture, you're mixing in with that 8% investment a 5% investment, and that's why you put in the 0.05. Now in this particular example, they're not telling you a final percentage or value or amount. They're simply telling you that you earn $476. So we'll go ahead and put that into place. Of course, it is the two amounts that they want. Now for our first amount, we'll simply represent it with a variable. But I cannot come over here, and I can't emphasize enough that we cannot come over here and use, for example, a different variable, because that would give us an equation with two variables in it, and that we can't solve. So you are not allowed to use a different variable. But of course you can't use x itself. That would imply that the money was split evenly and would sort of defeat the purpose of the problem. So we need to find a way to represent this second amount without using a second variable. And the way we can do that is to say, if we're investing a grand total of $7,000, and from that you've already put X dollars in at 8%, the rest of it, which would be 7,000 minus X, has to go into the other investment. Again, if you want to see how this works, you could pick a number for X. Say X was $3,000. Well, 7,000 minus the 3,000 would be the 4,000 that would go into the other account. Say X was $6,000. Well, 7,000 minus 6,000 would be the 1,000 that would go into the other account. So again, this problem, this type of problem, all these mixture problems, if you were to say there was any kind of trick to them, it's right here where we represent this second quantity without using a second variable. So now we're ready to solve. We start multiplying. And for that multiplication, we're going to have some help from the calculator. I'm going to take a 0.05, multiply it by the 7,000, and that's 350, so I can put that in. Then minus, still distributing here, the 0.05x, and that's your equal to your 476. So we combine our like terms. I get 0.03x plus 350 equaling 476. I'm going to subtract off the 350, get 0.03x equaling a 126 just from the subtraction. When I divide by 0.03, we'll again go to the calculator and we'll take 126 and divide it by 0.03, and from that we're going to get 4,200. So our x is 4,200. So that means, to interpret that $4,200 was put in the bank at 8%. And of course our grand total was 7,000. So I take the 7,000, subtract from that answer, I get $2,800 being invested at the 5% rate. So there's your first example of how the mixture problems work. Let's go to a new example. We're going to go to a pharmacy example. We're going to go to the pharmacy and mix together saline solutions. If we have a 60% saline solution that we're going to mix with a 25% saline solution, from that mixture we can get anything between 25 and 60%. You can't get a mixture that's above 60 or below 25, but we're looking for a 40% solution which is feasible, and we're looking to get 5 liters of that solution. The setup for this problem is going to be very similar to the setups we've already seen. Now, one thing that we're not given this time is the constant that goes over here on the right hand side. That we're going to have to find ourselves. So we'll go to the calculator and we'll take our final mixture, which is a 40%, multiply it by the final amount, which was 5, and from that we get a 2. So that's the value that we need to put on the right hand side. And we start filling in the other numbers. First ingredient was 60%, the other one was 25. The first amount is the unknown x, and the other amount will be what's left over from the total of 5. Now we start distributing. And distributing in this case is going to require some more multiplication, so back to the calculator. 0.25 times 5 is a 1.25 minus the 0.25x equaling the 2. Now to combine like terms, 0.60 minus 0.25 is a 0.35x equaling, and the 2 minus that 1.25, which was our last answer, is going to give us a 0.75. Now when I divide off the 0.35, I am going to find my amount divided by 0.35 to be a 2.14. So we get a 2.14, and again that's a little bit of a round off, but that's for x. The rest of it, which would be 5 minus the 2.14, is a 2.86, and those are your two amounts for the 60% and for the 25%, so that you can get a 40% solution. And again, sometimes a little bit of round off is necessary. Let's look at another example. Let's say next time around we're going to mix paints. Now when you mix paint, they can have different percentages of pigment within them, and you might have a percentage on hand that you want to mix to get a different percentage. Let's say we have 2 cans of paint. One of them is 2% pigment and the other one is 5% pigment. We can mix the two together, and from that we could get a 4% pigment. And we're going to mix these two and end up with 0.4 gallons. Again, the setup. You have 2 ingredients going in. 0.02 and 0.05 is what's going in. An unknown amount here, and the rest of it goes there. And we're going to set that equal to the product we get from multiplying. And again, we're multiplying this 0.4 times 4%. So 0.4 times 0.04, which represents 4%, is a 0.016, and we distribute. And again for our multiplication, 0.05 times 0.4 is a 0.02 minus 0.05x equals the 0.016. Combining like terms. Now this one, the reason this one was a little bit different is when you combine these like terms, you're going to end up with a negative coefficient on the x, which actually is okay, because when I do the other subtraction on the other side, the 0.016 subtract off the 0.02, I again get a negative result. And when I divide off the negative, go back and divide off a negative 0.03, I get a positive result. So again, another example of a mixture problem. Now let's look at one that's a little bit different for our final mixture example. Most of these examples have been taking 2 amounts, adding them together for a desired result. Let's go back to a money problem to see how the mixture problems can be set up slightly different. Let's say we had 2 accounts we're going to invest $20,000 into. So we've got $20,000 being split up 2 ways. One account is a 5%, one is a 7%. Now the instructions this time say that we want the interest to be the same. The interest earned in both accounts to come out the same. So we won't be adding these 2 ingredients together. We'll be setting them equal. 0.05 is the interest rate for one. 0.07 was the interest rate for the other. X is the amount that goes into the first one, and all the rest of the money, $20,000 minus X, is what shows up in the other one. So we're going to multiply 0.05x equaling, and again for that multiplication, going to have the calculators help. Remember, it was a 7% of 20,000, so 0.07 times 20,000 gives us 1,400 minus the 0.07x. We're going to bring the variable over by adding. Get a 1.12x equaling 1,400 when we add. So we're going to take the 1,400 and divide it by a 0.12, and that gives us 11,666 $2,000,000.67. That's the amount you put into the first account. For the second account, you take the $20,000 I had one too many zeros. That's $20,000, and subtract off the $11,666 and 67 cents, and that tells us the amount for the other account is $8,333 and 33 cents. So invest in the money like this would give you an equal amount of interest out of the two accounts. So there's your final example on the mixture problems, which that technique will work no matter what you're mixing, whether it's money or chemicals or anything else. Those mixture problems are always performed in the same way.